Surface area is the sum of the areas of all the faces or surfaces that enclose the solid. Now, we've already done a lot of surface area work, so this should be nothing new. It should be something that we should review, and it shouldn't take us too long to go over. Now, real quick, we've got some definitions and some terms here that maybe you need to understand. Notice on this first one, we have the bases. The bases are the two parallel sides. Okay, they're the two parallel sides that are repeated, and then we have what's known as the lateral faces. Remember, the lateral is the area around. Okay, then we have the base in a pyramid here. Okay, that base in a pyramid, there's only one of them in a pyramid or a cone, and then we have the lateral faces that go around there as well. Okay, and so notice here it says find the surface area of the prism, and so when I think about a prism, it's just a box, a shape. That's all a prism is. Okay, fancy name for that. So how many faces does this prism have? 6. It has a front and a back, a left and a right, and a top and a bottom. So we're going to go ahead and I'm going to refer to the front as this right here. Okay, so I'm going to go ahead and start with front and back. What is the shape of the front and the back? A rectangle. So what would the area of one of those rectangles be? 6 times 3, which is 18, but I have 2, so I really have an area of 36. Okay? Now I'm going to do the left and the right. Those are the sides. Okay, so here's going to be the left and the right. What are the dimensions of that? 8 times 3, which is 24, times 2 is 48. Okay, next I'm going to do the top and bottom. So here's the top. What are the dimensions, T and B? 6 by 8, you said. So the top and bottom area is 48. Take it times 2, you get 96. So now all I need to do is add all those together, and I get my entire surface area. So 6 plus 8 plus 6 is 20. Okay, 2 plus 3 plus 4 plus 9 is what? 18. So my area, surface area, will be 180 meters squared. Okay, like I said, we've already done this. Okay, it shouldn't be anything new. Now we're going to find the surface area of the cylinder. Okay, this is like a pop can. So my two bases are in the shape of a what?
A circle.
A circle. And so my two bases, so top and bottom, the area is going to be pi times radius squared, which is what? So radius is 5, so I end up getting 25 pi, but I have 2 of those, so my area of my top and bottom combined is 50 pi. Okay, the reason why the radius is 5 is because it's half of the 10. Remember, that will be 5. So now, does anybody remember what the shape of the cylinder in the middle is? Yeah. It's supposed to be a rectangle. And so if you remember with the rectangle, this is the middle. The height in this rectangle will be what? 12. Now I've got to find that distance there. Okay, that distance there is the same as this right here. That is the circumference. Yep, that is the circumference, which is pi times d, which is pi times 10. So the area of that rectangle will be 12 times 10 pi, which is 120 pi. What I'm going to do now is add those two quantities together. So my surface area of the cylinder is 170 pi inches squared. Questions? Now, say for example, it only gave you the radius. What you could do for the circumference here is take 2 times pi times r as well. Okay, so. All right, slant height. I don't know if we've talked about this ever. Have we ever talked about the slant height? Okay, the slant height is the height of each triangular lateral face. Okay, that's kind of a mouthful. the height of each triangular lateral face. Now notice that's different from the true height of the prism. The slant height is different, and you can see that in the diagram. The true height is going to be your vertical distance. The slant height is going to be, as you're looking on the side, it's going to be the height of each of those individual slanted figures. We label that L. Okay, we label the true height H. Okay, so now let's go ahead and look at an example. Okay, now this is what some formulas you need to get down. The area of the base for a regular n-gon pyramid. The area of the base for a regular n-gon pyramid, okay, is 1/2 A times P, or 1/2 A times B times N. What does A stand for? The apothem. What does P stand for? Perimeter. Okay. Now, let's compare those first two. You notice that the apothem is the same, right? So what would be the B and the N?
Base and number of sides.
Base and number of sides. Yep, good call. So B stands for the base, and N stands for number of sides. So essentially, okay, those are the same thing. Okay, it's just one, and you could actually find the perimeter every time and then take it times the apothem and take it times 1/2 and you should be fine. So now here's the surface area of a regular n-gon pyramid. So notice it's different. This is the area of the base. This is the surface area. Okay, so the surface area, once again, those should all look familiar. N and B, the number of sides and the base. L is what? What was L? Slant height. Okay. So there you go.
Oh, that's an
L. That is an L. Okay, once again, those two equations are similar in that the perimeter is going to be N times B. That's how you would find the perimeter. Now we've got another formula coming up, and that's going to be the surface area of a cone. So the next one is the surface area of a cone. Now notice that one, it's pi r times r plus L. Pi r times r plus L. Now notice on this one I didn't have an area equals. I probably should have. Okay, probably should have had A equals. So there, we'll make it look nice. And then we've got an example to look at. Find the surface area of the given cone. So find the surface area of the given cone. So I have A equals pi r times r plus L. So let's go ahead and plug in. What's r? 5. What is L? 10. So here we go. 5 pi times 15. Okay, so what does that come out to be?
75.
75 pi. What will my label be? Centimeters squared. Now where is something like this is important? Surface area, like when you think about those little snow cones, those little snow cone holders, companies would have to do this. They would have to figure out the surface area, and they would have to try and maximize their profit there. So that would be an example of where cones, surface area would be used.
Or like a birthday hat.
Birthday hats. Okay. So anyway, here's your assignment for tomorrow, page 466, 467, 1 through 12.